Hello everyone, this is Mr. Barasa and welcome to today's math challenge, and we shall still be looking at a question or a problem in logarithm. I had someone say in the comment section that logarithm is hard. I want to encourage you that if you get time you can still go back to school and you meet equipped and talented teachers, and trust me, you will come to realize that mathematics is one of the weapons that can be used to change poverty along or around your homestead. So let us look at the problem, and here we are given that log of x base 3 plus log of 3 base x is equal to 10 over 3. The only issue with this question is that the bases are not the same. But if one of the base is an unknown value and the other one is a numerical value, what we are going to do, we are going to do a very simple thing. Come and see. We have log of x base 3 plus log of 3 base x is equal to 10 over 3. Now, with this, for me to ensure that the bases are the same, I am going to recall that log of a base b is the same as, say, 1 over log of b base a. What has happened here? The base has changed. You can see log a base b. So what I have done here, I have just done the reciprocal of this. Like if you want to find the reciprocal of a number, it's 1 over that number. So that's the same thing I have done here. Now after doing this, we can do the same thing with our question here. We have log of 3 base x. Log of 3 base x is the same as saying 1 over log of x base 3. You can see now, try and do comparison. If you compare, you notice now that our bases are the same. Allow me to run this. Hope you have this information somewhere. Now, after doing that, what we are going to do next is that I am going to introduce another number, like a constant. I can say let log of x base 3 be equals to another value. Like I can say let it be equals to y. So whenever we have, anywhere we have log of x base 3, substitute it with y. So this will be, the whole of this is going to be y, and even this one is going to be y. So this one will be y plus 1 over y is equal to 10 over 3. Then from there, we find the LCM, 1, y, and 3. LCM. 1, y, and 3 is going to be 3y. Then we multiply across by the LCM. So when I multiply everywhere by the LCM, I will end up with 3y into y plus 3y into 1 over y is equals to 10 over 3 multiplied by 3y. 3y times 3y, we get 3y squared plus by y here 1, by y here 1. 3 times 1, you get 3 is equals to, by 3 here 1, by 3 here, you get y. 10 times y, definitely you're going to have 10. You will notice that the highest order of y is 2. In that case, this is a quadratic equation. So what we are going to do, we are going to rearrange to be in form of ax squared plus bx plus c is equals to 0. So bringing this 10y to this side is going to be minus 10. I have arranged so that it can conform to this form. This is what we mean by a quadratic equation. Now we're going to solve the quadratic equation. And there are so many methods, several methods that can be used to solve this problem. So today I want us to look at factorization method. Sum and product. Sum is the coefficient of b. This is the coefficient of b, negative 10. Product is the coefficient of a times c. A multiplied by c. Our a is 3. Our c is also 3. So we're going to have 3 times 3. The result is 9. Now after that, we're going to look for two numbers, whereby if you add the numbers, the result is negative 10. And if you multiply, the result is 9. How do you get those numbers? Now, what you need to do, just look at the product. Our product here is 9. Try to take all the numbers that you can multiply and get the result as 9. Let us try and see the multiples of 9. I can have 1 multiplied by 9. I can also have 3 multiplied by 3. Those are the only number that we can multiply, and at the end of the day, we have the result as 9. But now, after that, you do assessment. You assess. You try and add them and see if the result will be equal to negative 10. Let us add 1 plus 9 is 10. 3 plus 3, 6. Definitely, I'm going to disregard that because the sum is giving me a value that is lower than what I'm expecting here to be 10. So the values here will be 1 and 9. But now, due to the fact that we have a negative number here, what we're going to do, I'm going to introduce two negatives. I'm going to have a negative 1 and a negative 9. Remember, if you add two negative numbers, the value becomes more negative. And when you multiply two negative numbers, the result is positive. Therefore, negative 1 multiplied by negative 9, we are going to have it as positive 9. Then now, these are the coefficients of b. They will be standing in for b. So, we are going to have 3y squared minus 1y, which is the same as saying minus y, minus 9y plus 3 is equals to 0. Then introduce brackets like that. By introducing the brackets like that, you factorize now. You simplify the brackets. 3y squared minus y. The common factor of this is y into 3y squared divided by y. We have it as 3y minus y divided by y. The result is 1 minus, this is 9y plus 3. Common factor is 3. Remember, these two brackets must be the same. They must look alike. So we have minus here. 9y divided by 3, we get 3y. 3y divided by minus 3, we get it as minus 1. Now you see, two brackets. Then you equate it to 0. So after that, allow me to wrap here now. After that, we are going to merge the two. Y minus 3. Out of the two brackets, we just pick 1 is equals to 0. How do we get the value of y? We equate everything here to 0. Y minus 3 is equals to 0. Definitely, y is equals to 3. And 3y minus 1 is equals to 0. Definitely, y is equals to a third. But remember, we are not looking for y. We're looking for x. Now, and we had said that log of x base 3 was equals to y. But now you see our y is here. So I'm going to say log of x base 3 is equals to the values of y. I'm going to substitute. And log of x base 3 is also equals to a third. Because I have two values of y, it means I must have two values of x. Then after that, we're going to use the laws of indices. Remember, if there is a way you can convert a number from logarithmic form to an index form. So that's the exact thing I'm going to do. If you have log of a base b is equals to c, this is the same as saying b raised to power c is equals to a. That is what I'm going to do. So this one is going to be 3 raised to power 3 is equals to x. Then x is equals to 3 power 3 is 27. The other side we are going to have it as 3 raised to power a third is equals to x. A third is the same as saying cube root. Definitely this is going to be cube root of 3. And this becomes the values of x. When you substitute the values of x in the original equation here, you will end up having the result as 10 over 3. I hope that you've learned something. And this was our today mathematics challenge. Thank you and have a wonderful time. Bye bye.